My name is P. and I do in the class CSCG section of subject operating system. And today our project is multi-level queue scheduling algorithm for multiprocessor. Understanding multiprocessor scheduling course outcomes. Students will comprehend how multi-level queue scheduling is used to manage tasks efficiently in multiprocessor system. And the second course is task prioritization. Learn to classify tasks into appropriate queues based on priority and type for optimal resource utilization. Algorithm design skills. Develop skills to design and implement scheduling algorithm that handle preemption and dynamic task allocation, and for the outcome is gain the ability to evaluate the efficiency of the scheduling algorithms in terms of throughput, waiting time, and CPU utilization. And the fifth outcome is dynamic load balancing, understanding techniques for dynamically rebalancing tasks across processors to prevent bottlenecks. The sixth one is practical implementation, translate theoretical scheduling concepts into real-world programming and evaluate them in simulation or real environments. The title of the project is also separate design a multi-level queue scheduling algorithm for multiprocessor. Let's look into what is multi-level queue or what is multi-ML queue or called CPU scheduling. Multi-level queue CPU scheduling is a type of that is applied at the operating system level with the aim of sectioning types of processes and then being able to manage them properly. As with the MQ series, processes are grouped into several queues using multi-level queue based on own parameters such as priority memory or type. Every queue has its or in the same queue or very similar to. This article will explain the multi-level queue in detail of the project overview. What is a project overview of a multiprocessor system? Efficiently scheduling of tasks is critical to improving performance, system throughput, and resource utilization. Multi-level queue (MLQ) or we call short formally scheduling algorithms aims to manage tasks by categorizing them into different priority queues, ensuring that higher priority tasks are given precedence while maintaining a balance between different levels of processing resources in multiprocessor environments. The multi-level queue scheduling algorithm divides the ready queue into multiple levels, with each level having different priority. What are the priorities and what are the scheduling policies? Let's discuss tasks. First of all, tasks are the assigned to queues based on their attributes, and the examples of the task are priority, execution time, or type of workload which are given to the system. These queues are serviced in a predefined order. The main focus of this project is to developing scheduling algorithm resource allocation across different levels of the queue. The process real-time executed as soon as possible, while lower priority tasks can be managed with fairness using techniques like round robin or FIFO. What is round robin scheduling? Round robin scheduling is a primitive scheduling algorithm that gives processes equal time to run in a circular order. The round robin examples log method of scheduling where each participants play against all other participants in the event, then be a sports team like those. This is also referred to as a round robin tournament. Design and implementation. To design a multi-level queue scheduling algorithm suitable for multiprocessor systems. Performance optimization. Enhance system performance by allocating processes efficiently, minimizing task wait times, and improving throughput. This task categorization classifies tasks into distinct queues based on priority levels and resource requirements, fairness and responsiveness. What are these are the objectives? What is fairness and responsiveness? Ensure that both high priority and low priority tasks get appropriate CPU time when they are comparing the two to CPU time, the high priority and the CPU low priority CPU having the equal time and the equal clock speed with the minimal starvation. Scalability. Ensure the algorithm scales well for systems with a growing number of processors and tasks. There are prerequisites and requirements of this project. Understanding of scheduling algorithm. Knowledge of basic scheduling algorithm like FIFO, first in first out, round robin, and priority scheduling. Operating system concepts, multiprocessor systems. These are called the prerequisites. Let's first see the understanding and scheduling algorithms and the next operating system concepts. What are operating system concepts and prerequisites? Understanding the basic principles of operating systems including processes, management, queues, and context switching. The next multiprocessor system. Understanding of how tasks are distributed and managed in a system with a multiple processor. And then requirements. Programming language like Python, C++, or Java. Regularly, Python is commonly used for simulation-based projects due to its simplicity and extra requirements of its data structures. First, we have to understand in arrays, list, priority queues, linked list, implementing the multi-level queues effectively and their algorithms. And the concurrency, one of the requirements. What is a concurrency? Knowledge of managing process in a concurrent environment includes task synchronization. The last one requirement is performance analysis tools. Tools or techniques to measure the performance of the algorithm. And the examples of average waiting time, turnaround time, CPU utilization. And then what are the technologies used? Python for implementation and simulation performance, infrastructures, libraries, threading, matplotlib for visualization, threading is for simulation, time module for measuring execution time and calculating delays. These are the code for the multi-level scheduling, and then it is output. Conclusion and the future enhancements, dynamic priority adjustment, real-time scheduling.
My name is B.V. Rajay. Today my topic is about multi-level queue scheduling algorithm for the suitable support for multiprocessor system. This slide represents the execution of this project topic. We have to import the queue, import the random and import the time. Next we have to create a class. Name is consists of process and next line indicates the def function. In it, it consists of the self, speed, priorities and bus time. By using the self keyword and dot operation and the method, we have created the object. Self dot bit is equals to bit, self dot priority is equals to priority, self dot bus time is equals to bus time. And then we created the class multi-level queue scheduler. Again we created a def function which consists of self and processor. In this processor there are three types: higher priority processor, lower priority processor, medium priority processors. We are using these methods with a keyword as self and dot operation to create the object. Self dot high priority dot q is equals to q dot output. Self dot medium priority q is equals to output dot q dot output. Self dot low priority q dot output. Self dot processor is equals to q dot processor. Next we create def function as def add processor self comma processor. By using the if processor dot priority is high, we should do that self dot high priority of q dot put processor. By using elif condition, processor dot priority is equals to medium self dot medium priority space dot medium priority q dot put processor. By using else condition, self dot low priority q dot put the processors. Def scheduling of self. While not self dot using the while condition, it does not satisfy all queue empties for I is requested in self processor. If self dot processor of I is none and self dot processor of I and self processor I are requesting times is equals to 0, self dot processor of I is equals to self dot dispatch processor. If self dot processor of I print the process as present on the line, executing process of the self dot process is equals to remaining time. Self dot processor of I dot remaining time is equals to -1. If self dot process remaining time is equals to -0, print the processor of the completed processor of self dot process at the pid and returning as a time sleep. Again we create as dispatch process self. If using the conditions if and elif and else, we solve this condition. If not, self dot high priority queue is empty. Return self dot high priority queue dot get elif. Not self dot medium priority queue dot empty. Return self dot medium priority dot queue dot get. Elif not lower priority queue dot empty. Return self dot low priority queue get. Return none. Def all queue as empty. Return self dot high priority queue empty and self dot medium priority queue dot empty and self dot low priority queue is empty. By using this dispatch process, we should identify that self dot high priority, if it is empty, we have to get it by the return statement. After this, we have created as a main method as scheduler is equals to multi-level queue scheduler for the processes. By using the first statement for I in range of 10, priority is equals to random choice of high and medium low as categorized between tree, medium and low high. Burst time is equals to random int of I comma 10. Processor is equals to process of speed is equals to I plus 1. Priority is equals to priority. Burst time is equals to burst time. Scheduler dot add process. By adding this war processor mid with the process priority and burst time, by using the print statements /n of scheduling /n. Scheduler dot schedule has been created. By using the print statement, we can print the output as in how many processor has been high and how much time it's take place. We can get them in output as added process 1 with priority high and burst time is 5 and processor 2 with priority low and burst time 3. Added process 3 with priority medium with burst time 4. Starting scheduler. Process 1 executing process 1 remaining time 5. Process 2 process 3 remaining time is 4. Process 1 executing process 1 remaining time 4. Process 2 executing process 2 remaining time 3. Conclusion. The multi-level queue scheduling algorithm for the multi-process system provides an efficient way of managing tasks with verifying priorities. This system ensures that high priority tasks receive the necessary resource first, while still allowing for fair execution of lower priority tasks. This can be further optimized by considering dynamic task characteristics by introducing agenting mechanism to prevent starvation of lower priority tasks. Future improvements and enhancement. Task aging. Implementing aging mechanism to prevent the starvation of low priority tasks. Dynamic priority adjustments. Dynamically adjustment task priorities based on changing conditions. Real-time scheduling. Implementing real-time task management strategies